All right, everyone, welcome back to day 2. So hopefully yesterday went okay, talking about how to find what a radian was, how many radians are in a circle, and hopefully you were able to check some of those answers. I posted the keys so you could check your work from yesterday. Remember, I'm here and available every day at 2:05, but you need to reach out to me. So if you're struggling, it's okay. That's what I'm here for. I don't want you to feel like you're on your own, but I need you to make sure that you're doing a good job of checking your own work. Okay? So I'm trying to use the projector today. I'm hoping that you can see the board okay. Maybe my face looks a little dark. Maybe you can't see me. But I'm open to feedback. So if this video stinks, just email me and then I won't do this again. Okay? So here's our goal today. We are going to start developing something that you maybe have heard of before, maybe not. Something that's called the unit circle. Okay? Have you guys ever heard of the unit circle before? Have you heard of that? So what is this so-called unit circle? Well, it's a circle. We know that. And the unit part is because the radius of this circle is 1 unit. So it could be 1 foot, 1 centimeter, 1 meter, but the radius is 1 unit. And it's centered at the origin. So it's the most basic circle that you could possibly draw. So if I was going to graph this, here it is. The radius is 1 and it's centered at the origin. Okay? It's called the unit circle. Now, why do we choose this unit circle? We choose this unit circle because if I know stuff about this unit circle when the radius is just 1, then I can scale that up and down very easily to find stuff about other circles. So let's say I had a circle that had a radius of 5. Well, anything I know about the unit circle when the radius is 1, all I would have to do is multiply all that by 5, and that would give me everything I wanted to know about a circle with a radius of 5. Okay, so it's a very friendly circle that we can use. All right, so today we're just going to focus on the angles of my unit circle. Okay, that's what we're going to focus about. All about how do we draw the angles, and we should feel decently comfortable with this if we did the homework from yesterday. Okay, so first of all, there's a couple of different lines on your paper here. So you'll notice that there's this outside, it's talking about the angle in degrees. We have that degree symbol, and then the inside line is talking about the angle in radians. So we're really going to focus on using radians in this class. So I might write in the degrees just so you can see it, but almost everything we're going to do is using radians and not degrees. We want to kind of get away from degrees a little bit, and we'll see some different ways that radians is more useful throughout the year. Okay, so first things first, we said yesterday to draw these angles, I'm always going to start by facing this positive x-axis. Okay, it's called an angle in standard position. I'm always starting here, and then I'm always opening up counterclockwise. That's how we're going to draw an angle that's in standard position. Okay, so let's focus on the first quadrant first. So if I face this way and I don't open up at all, well, that would be an angle of 0 radians. Okay, that's easy enough, right? So if I'm standing here facing this way and I don't rotate at all, my angle is 0 radians. Okay. Now, these 3 angles in the middle, mathematicians chose these angles because they're nice and they're friendly angles. Okay, so there are an infinite number of angles on this unit circle, right? I mean, if we wanted to think back to degrees for a second, I could draw 1 degree, 2 degrees, 3 degrees, 4 degrees, 5 degrees, 6 degrees. So it's not like these are the only angles that exist on this circle, but we focus on key angles that are going to be easy for us to work with. Okay? And in fact, I think I'll tell you what the degrees are first of these angles, just so you can see. So this first angle is 30 degrees. This middle angle is 45 degrees. And then this top angle is 60 degrees. Okay? Now, why these angles? Why not 10 degrees? Why not 15 degrees? And part of the answer is we know things about 30-degree angles, right? You don't have to draw this, but if I drew this straight down, which we'll do in a couple days, I end up with a right triangle here, with a 30-degree angle. Okay? And you guys just took a quiz talking about 30, 60, 90 degree angles, right? 30, 60, 90. And then we took a quiz about 45, 45, 90 right triangles. And then 30, 60, 90 again. And so we know things about these angles, which is why we choose these angles. So mathematicians made these angles up because they're nice and easy to work with, and that's really the only reason why. Okay? So 30, 45, 60, and then you guys know that this angle is 90 degrees. Alright, so then what about radians? Okay? Well, I think I'll just tell you this for now, and I'll show you how I knew in a little bit. But this angle right here in radians is pi over 6. So that's kind of a big one there. Pi over 6 is an important one. And again, mathematicians chose that. We know that's equal to 30 degrees, which I'll prove to you later. And then this angle right in the middle is pi over 4 radians. Okay. So, really, those are the only two angles that you have to memorize. Okay? Everything else, if you know how to count, do you guys remember counting? 1, 2, 3, 4, 5. Do you guys remember how to count? If you can count, you can find the rest of these angles. It's really easy. I'm going to show you. Okay? So pi over 6 is this angle. Pi over 4 is the middle angle. Now, the pi over 4 one, we actually talked about yesterday a little bit because we said this angle right up here, a quarter of a circle, that'd be pi over 2 radians. Okay, pi over 2 radians. So then it makes sense that half of that would be pi over 4. So halfway in the first quadrant would be pi over 4. Okay, so let's start with all of these middle angles in each quadrant. So let's start the middle angles, and let's put our x and y axis here. Okay, so like I said, the only skill you need to have to figure out these angles is to count. We're just going to count up by pi over 4. So we're going to skip these other angles for a second. We're just going to count up. I guess, what would this be? Technically, an eighth of a circle. We're going to go up by an eighth of a circle. Are you guys ready? So 0, 1 pi over 4, 2 pi over 4. Well, 2 pi over 4 reduces to pi over 2. Sorry, I have that one. Okay, what happens after 2 pi over 4? 3 pi over 4. So this angle right here is 3 pi over 4. Do you guys see what we did there? 1, 2 pi over 4, 3 pi over 4. What happens next? After 3 pi over 4, we have 4 pi over 4. Well, 4 pi over 4, that reduces to pi. Okay? Okay, 3, 4, 5. So this angle is 5 pi over 4. What happens after 5? 6 pi over 4. 6 pi over 4, that reduces to 3 pi over 2. We talked about that one yesterday. 5 pi over 4, 6 pi over 4, 7 pi over 4. Okay? So all we have to do is remember that one angle is pi over 4, and then just count to fill in the gaps. Alright? Now, let's do the same thing with pi over 6. So I'm just going to go up by pi over 6's and fill in the rest of my gaps here. Okay? So, another way, if I go up by 30 degrees, I have 30, 60, 90. So I'm just going every 30 degrees for every pi over 6 radians. So here we go. So pi over 6. So this is 2 pi over 6. Does that reduce 2 pi over 6? Yeah, it does. That's pi over 3. So that's another big one that we are going to need to remember. So 1 pi over 6, 2 pi over 6, 3 pi over 6 reduces pi over 2. We already have that one. 4 pi over 6, that reduces 2 pi over 3, 4 pi over 6, 5 pi over 6, 6 pi over 6 reduces just pi. So the next one, 7 pi over 6, 8 pi over 6, but 8 pi over 6, that reduces 4 pi over 3, 9 pi over 6 reduces 3 pi over 2, so 7, 8, 9, 10 pi over 6, that reduces to 5 pi over 3, so that's 10 pi over 6, 11 pi over 6, and then 12 pi over 6, 12 divided by 6, that's 2 pi. So we could also say all the way around the circle is 2 pi radians, which we talked about yesterday. Oh, look, we did it. All I had to do was know this is pi over 6, this is pi over 4, and then if I know how to count, I can fill in all the angles of my unit circle. Okay, so that is a huge piece of memorizing the unit circle, is just kind of remembering where those numbers come from. Okay, so here's what I want you to do. On the back of this piece of paper is another blank unit circle. I want you to pause the video, flip the paper over, and without peeking, see if you can fill in all of these angles. So don't peek. If you mess up, that's okay. But remember, all you need is pi over 6, pi over 4, and then count. So ready, pause. Okay, how'd you do? Did you get them all? Did you miss a couple? So knowing these angles is just gonna, I can't express how important it's gonna be, trying to memorize where they are and just being comfortable with those. Okay, now if you want to, you could go back in and fill in your degrees too, right? 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, 360, and then go to the 45s. 45, 90, 135, 180, 225, 270, 315, 360. So we can fill in those angles. That might be a good idea, just so you have those. But really, we're going to focus in on those radians. Okay? So here's what I want you to do. I'm going to ask you to draw some angles for me. So if you can find a blank piece of paper, I'm going to throw some on the board, and we're just going to practice drawing them just so we can get comfortable with that. Okay, so just trying to get more comfortable drawing these angles, especially maybe some wacky ones. But a huge key for this, really the rest of the year, is when I say 7 pi over 4, in your head you already know where I'm at. You know which quadrant, you know approximately how to draw that, so on and so forth. Okay, so right now we're not great at it probably, but if you have some extra time, draw a blank unit circle, throw in the angles in there real quick. You know, maybe try to go backwards, get crazy with it. And I'm going to force you to do that. If you scroll through that packet, you've probably seen the unit circle on there a few more times. Okay? But today we just want to practice drawing these angles. Okay? And we're going to do this more tomorrow too, but just a little preview. So, first of all, when I draw these, remember that I'm always going to start by facing the positive x-axis. Okay? So I'm always going to start there. And then I'm going to open up counterclockwise. So 7 pi over 4, how do I draw this? Well, here's what I'd like you to do. I'd like you to pause this video and see if, without the unit circle first, can you draw these angles? And then, if you get stuck or just check your answer, maybe have your unit circle next to you and see if you can draw it. Okay? So, see if you can draw these. Actually, I'll do one with you just so you know what you're looking for. So 7 pi over 4. Well, if you look at your unit circle, it's down here in the fourth quadrant, but I want to draw the angle. So to me, what that means is I'm going to wrap all the way around to where my angle is, and I'm still going to draw that angle, but you have to make sure you have this arc with that arrow on there. Okay? Pretty soon we're going to be going backwards also. So you have to tell me which way is that arc opening up. And then, based on the fact that 7 pi over 4 is less than 2 pi, but more than 3.5 pi, I know that I'm going to be here in the fourth quadrant. Okay? So that's what we're looking for. So go ahead and pause, see if you can draw these angles. Okay, so 4 pi over 3, that's on my unit circle. I know it's more than 1 pi, which would be here. It's less than 1.5 pi, which would be here. So we're somewhere here in the third quadrant. Okay, notice I put my arrow on there with my arc. Over here, 13 pi over 6, I like to write that as a mixed number, so 2 1/6. Ooh, okay. So 2 pi is to be all the way to there, and then 1 pi over 6, that's on my unit circle, so pi over 6. So there's that angle. So make sure you show that I went all the way around once, and then I went a little bit extra. And then the last one, 23 1/4 pi, is this mixed number. Ooh, I got some drawing to do. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 23, and 1/4. So I need all those loops so that I know what's going on.